Welcome, thank you Monty, by the way. Welcome to the Blindheim Passive House. It's on Blenheim Street, but since everything in Passive House is German, so too must be the name. And the German version of Blenheim is Blindheim. So again, my name is Ian Robertson. I've been in Vancouver since 2011, and this is my first Passive House. So I figured let's toss everything in that I can. Passive House consultant who helped me greatly was Pierre-Andre Santa, and he's online as well, and he can help me later answer some questions that I've forgotten, because it's been a little while since I designed the thing. And okay, so I love this is one of my favorite quotes, and I've got my own version of it. I love rules. I love the creaking noise they make when they get pushed to their limit. It's not the best quote, maybe. But the standard one that I kept hearing when I got into Passive House, although it's been disproved many times kind of since, is that Passive Houses must have small windows. And I took that as a challenge. So the Blindheim Passive House, again, it's in Vancouver, north-south orientation lot, a little bit wider than normal, which helps out a lot, actually. The normal 3-foot lot gets a bit tight. Limited views to the north, but present, so you know, we had to have windows kind of on all sides. So I couldn't do this as much as I would like to. And this is actually a design from A.A. Robbins. So no windows to the street is actually a precedent here. And the client specifically didn't specifically want a passive house per se, but they did want all of the superlatives that a passive house does. So when I kind of added all of these things together, it's, you know, each one of these has a little bit of an additional cost over what a bog standard thing might be. So, you know, why not actually just put them together and do it properly? And then the fact that at that time, there was a bit of a bonus for doing a passive house in terms of permitting, that certainly didn't help either. And this has come down in Vancouver, it's become a little bit more normal, but for a while it was like nuts to get a permit in Vancouver. So that was a big motivation. So the project zoning, it's in an RS5 zone, which is one of 33 different residential zones in Vancouver. It's impossible to remember them all, so I try not to. But basically, most of them are RS1, you get a peaky roof with some weird steps on the side. RS5, at least you get a big boxy thing if you want it. But if you want to go as high as you could, you have to do a peaky roof of some kind. Peaky roof in that, though, means less head height on the edges, unless you do a butterfly roof. And then you get the best of all worlds, and that's exactly what I did. Instead of doing just a standard butterfly roof, you can crank it a little bit and make it a bit more interesting. And then this is the initial design studies, and essentially it hasn't changed at all since the sketch on the bottom right. So it just has to have a minimum of 712 pitch. Doesn't say that you can't have more than one of them, and so toss two of them together and you've got a great roof. So the massing diagram is basically a block on top of two chunks with a glass in the middle. Pretty dumb, but in this case, you know, dumb is good, simple is good. And I mean, that's what Passive House relies on a lot. So you enter into the basement because I wanted to have the entire house as much as possible above grade and functionally above grade. Because honestly, basements don't really help anybody. But in Vancouver, you're required that about a third of your area is in the basement. To its detriment, but whatever, you can't change it, so let's break this rule. Too hard to see this drawing, but so from early concept model to render to reality. You know, pretty legible, pretty simple, follows the same lines. On the south facade, similarly, we've got some pretty big glass. And then henceforth, I'm going to be measuring my glass in Stevens, because, you know, why have small windows? You don't need to have them. This is literally the biggest glass actually we can get on the West Coast without having to go to funky European glass, which costs more. And in this case, we've got 2.1 Stevens by 1.6 Stevens, which I think is a pretty good measure. It's, you know, pretty good sized glass. So, they have small windows. No, they don't. You can do a butterfly roof to make best use of area. If you raise up the basement as much as possible, it doesn't have to be dark. And if you mean the floor above the basement is really, really skinny, you don't have to drop it down on the ground very much. So built, you know, it was very normal to start out with just gravel, minimal penetrations, big whack of foam underneath. It was supposed to be GPS. We changed it to EPS because it was way cheaper for some reason. Then used a nice commercial grade membrane system, ran all the HRV pipes essentially through the slab. The thing is, this is about the only concrete in the whole project. Once that was poured, although we could have reduced a little bit if we'd coffered the underside. So basements are slow to make and are carbon intensive. Well, why do they have to be concrete, and why do you have to build them on site? These exist. These came out of Alberta. So these are a magnesium oxide skinned SIP panel. So it's basically an advanced frame wall with treated lumber inside. And then you're not relying on a concrete foundation for your waterproofing anyway, honestly. You're relying on your membrane. So use a good membrane with these things. And you get a basement which, instead of being R0, is R50 something, you know, with minimal outside insulation than needed, instead of having to backfill 12, 14, whatever inches of insulation you might otherwise need. So, you know, yeah, we were really careful about the waterproofing system and everything like that. We've got a good commercial system. So the interesting thing is basically everything above the slab then is digitally designed and fabricated and with shop drawings and everything like that. So if you visited the site, you noticed the hoarding. That hoarding was actually my shop drawings. I figured I might as well just put them on display so people can understand the thing. So, you know, it introduced the project, but it also showed all the main components of the whole house. This is beyond the raft slab and the SIP panel basement. We use Simpson panels to create a moment frame on the cheap. So these things are way simpler to use than a big steel frame. Thermally, it's way better as well. Big glulam beams on the top, connecting everything together. NLT floor for the basement suite because it has an intrinsic fire rating. LVL floor, although the manufacturer calls it mass plywood, for the office level to make as thin a floor as we possibly could have. So that floor is only 4 inches thick. That means that the basement doesn't have to go very far on the ground. So this is the LVL being put on place. And glulam beam just on the edge, also very, very skinny. So then I ended up actually doing the shop drawings for it because the manufacturer was just getting up and running and they didn't really have that capability yet. Probably the last time I want to do that, but it's possible. And it's a nice product. So houses need internal walls? No, they don't. Clear spanning structural systems exist. Might as well use them. In this case, it was DLT, so dowel laminated timber, another fairly new product to the Vancouver market. Longer history in Europe. And then that used a little bit of steel perpendicular to the span to go in with a couple inches more concrete to make it a hybrid structural system to allow 2x8s to span 26 feet. It's a long way to have only 2x8 span. It was a bit wobbly and bouncy before the concrete went on, but as soon as the concrete was there, then it was bomber and like, it was really impressive. So this is from StructureCraft. And I counted it, there's actually 6 different flavors of mass timber. On this, the thing that I'm not missing was a couple headers or PSLs. But it's interesting because the Simpson panels are essentially just big OSB. And all of these things were used basically for significant structural reasons. It might seem weird to have this many, but each type of mass timber has its things that it's good at. So this house is basically tuned to use the things that it's all good at. Regular SIP panels for the rest of the shell. Mostly 12 inches thick, some 9 inches to allow the mechanical chase on the east wall. And then big glulam beams spanning side to side about 24 feet. The pink coating is actually a fluid applied WRB, which was the substrate for the EFIS skin that went on later. And I thought, well, as long as we've got one layer on anyway, the manufacturer had pre-applied stuff before for use in schools. And this gave the house a nice umbrella because, you know, it does rain here in Vancouver. So why not, because these things are OSB and you know, it's a bit of a risk, let's ameliorate most of that risk by pre-coating them. This is why I wanted to use the shop drawings that were in 3D and not have to tell the SIP company in 2D how to do it. I didn't want to have to figure out all these angles, and because I just give them the 3D model, I didn't have to. It's great. So the whole thing then could go together pretty quickly. And then as soon as the SIP panels went up, then they could have their seams all taped. And essentially for a little while, it was a cathedral inside. Anyone who did the Passive House social in this space, I really wish I had like videotaped a cellist or something like that. It was pretty cool. Of course, you know, walls came into this space later, so it lost a little bit of that coolness. But still, it made for a tremendously simple envelope system too, because it was just one SIP panel line the entire way down to the basement, 4 inches of external insulation everywhere. So it just became really easy to line up all the different layers. There's a couple through wall flashings in between. And this makes it really easy to do a really good air test when you've got fluid applied WRBs, really good sealing, really big panels. You've got no place for air to go. So in this case, a preliminary test was actually 0.15, which is not so bad. Caveat is that was done before the big windows were put in. I don't have the data for the more recent ones. So this was the shell and the upper windows only, and then poly off for the rest. So the poly will perform better, so the house will perform a bit worse, but that's going to be the ballpark. I was interested to see this window detail at BCIT. So this is a local school that teaches Passive House people in Vancouver. And using this interesting fiberglass angle, and that's exactly what we did for ours. So the north windows are sitting on the fiberglass. It's thermally about the same as wood, so it makes it really easy to hang a big window on something that has very little thermal bridge. To help that out a little bit, we did use a little bit of heating. If it had been a floor covering on this floor, we could have used like a in-floor wire. In this case, we'd have the mass timber only, so we had to do something that could be applied on the surface. So this was something used more for like roofs, for doing heat tracing of gutters, but it works perfectly indoors as well. So big windows, of course, require big cranes. These windows are 8 by 9 feet, so not that big. The ones on the south side are bigger. As I mentioned, those ones are the ones measured in Stevens. So it's an EFIS coating on both levels, tooled to look like concrete on the lower level and just pure white up top. And then all the gutters are actually running sort of externally, sort of internally. So it's outside of the WRB, inside of the EFIS coating. So if there was ever a leak in here, you don't really have to care too much because it's easy to address if there was. So it's basically the least risky way of doing a internal gutter, and that's pretty and architectural and makes me happy that you can possibly do. So we use these copper boxes that were custom made to go through a little custom parapet cap, and the pipes just go through 2 of them so that it can fit within the 4-inch EFIS layer. And then you can see how all the structure just perfectly lines up. You've got a little bit of external insulation with some through-wall flashings, otherwise everything just sticks on top of each other. It's the simplest thing in the world. So with some actually very nice tooling on the EFIS to make the concrete pattern. So I was really impressed with these folks. I'd use them again. Outside of the house at that point was mostly finished looking. Inside was like this. So the inside lagged the outside. And here you can see the DLT, the LVL, and a few of the other things. The LVL we actually used for some of the walls and also the stairs and a bunch of other things. Because I thought might as well treat it like furniture as well. Use furniture out of plywood, so let's just scale it up about 10 times and make it out. Mass timber mains toilets are a bit tricky, so we actually had to do wall-mounted toilets so we could have the pipes run through the wall everywhere. That was the main annoyance, really. Everything else wasn't all that tricky with it. So there's furring cavity everywhere. Initially, this was going to have insulation in it. We were able to eliminate all that insulation because of the really good air test. So, about $20,000 of rock salt went out the window, which was useful. So this was just for drywall and that's it, and for services, and made it a lot easier to do everything. So you can see all the tape joints on the panels outside and inside. Living room, then we propped up the floor to camber the floor a little bit, so when we poured the concrete, it then settled flat. And then this became an interesting, so the interior and exterior you can see with the, where the roof deck is. Normally the situation would rely either quite a big step down or quite a big step up to get enough insulation. Whereas I did this instead. So this is using a skinny SIP panel and then vacuum insulation above it. Vacuum insulation in this case, it's just sitting there with gravity. It's the easiest way you could possibly use it. This was some like overstock stuff from Panasonic, which is actually really cheap. Even at cost, even at like normal cost, it's only about $8 or $10 a square foot though. So it's really not that bad compared to its insulated value and how much benefit you can have in this situation. It does require a lot of care when you're putting it in. So everyone on site didn't let the roofers do it. Contractor did it. Quickly did it when before the roofer was going to do it. Put the insulation, put the board on top to protect it, and then the roofers put the roof on the next day. Mechanical systems ended up being a little small. I think there's some squares were set at me. You can see both sand tanks at the bottom of the shaft there. HRVs were on top. It worked. I planned it out ahead of time to know that it could work. It was just tight. So, but in a house in Vancouver, real estate's at a premium, so you can't not have tight things, basically. Here's the living room before we started doing any furnishing, any layers, so you can see all the guts. Some of the nice mass timber. So these were essentially just offcuts from that floor that we got to use then everywhere else. So all the stair treads are chunks of mass timber. Ends up, being nice that you can have this stuff featured then really nicely. So the final living room then, the lights ended up being a little bit heavy. That was an interior designer's decision. But otherwise, it makes a pretty good room. So it's 25 feet wide by about 35 feet deep. It's about as big a room as you could possibly make on this lot in this city. So, it's a pretty good space. Basement suite has exposed NLT ceiling on half of it. So that's using the specific fire rules that allow one depth to have one fire rating and a smaller depth with drywall also to have the same fire rating. In the office, the ceiling gets the very similar look, but this time out of DLT. And it went DLT instead of NLT because we literally couldn't get 2x8s long enough to clear a span without going to Alabama and ordering a train car full. The EFIS ended up being tooled really, really nicely. I was impressed with these guys' work. They really embraced really clean architectural details. And of course, because of that parapet and internal gutter detail, I didn't really have to have overhangs while still having good factor of safety with my envelope system. And then here's the house basically done. This was a couple days ago. You can see the gutter on the roof basically starts at 0 when it's on the ridge and then drops down to about 8 inches deep when it's on the corners. Because of course you don't need a gutter when you don't have any roof slope to feed into it. So that's why it pitches up proportionally with the roof drop. Good also cutting the carbon footprint down when you're doing all your site reviews on a bike. And then using some Okoya to keep it exposed for the front entry porch. So the whole house went from this to this. And I have absolutely no idea where I am for time, but that was it. I think I went through the slides a little faster than I thought.